Good morning, children. Children, as you all know, we have started with lesson number 1, Laws of Motion from Science Part 1 in our previous video, right? And previously, we have learned that in laws of motion, the terms about displacement and distance. Do you remember, children? What is distance and displacement? Distance is the length of actual path travelled by an object in motion while going from one point to another, while displacement is the minimum distance between the starting and finishing points. Today, children, in this video, we are going to learn about speed and velocity. Okay, so let's begin. Now, children, before learning speed and velocity, let us understand some terms related to speed and velocity. First is physical quantity. Now, what is it? Anything that can be measured is called as physical quantity. For example, distance. Now, children, we can measure distance, right? In centimeters, meters, kilometers. So, that is a physical quantity which we can measure. Second example is time. So, we can measure time, right? Seconds, minutes, hours, days, week, even sometime years. So, children, these quantity are physical and we can measure them. So anything that can be measured is called as physical quantity. Understood? Now this physical quantity, it is divided into two, scalars and vectors. Now what are scalars quantity? Physical quantity which can be described by magnitude only. For example, time, mass. That means if that quantity which we can only measure. So time we can measure like seconds, minutes, hour, right? And mass. That also we can measure like gram, kilogram. Okay. So the physical quantity which can be described by magnitude only is known as scalars. Now let's see vectors. Physical quantity that requires magnitude as well as direction to be described is known as vector. Here the example is force, displacement. Now children, as I said, magnitude means to which the substance which we can measure, right? And direction. Now let's take an example. If I need to move a chair, okay, from a room to the left hand side. Okay, what am I telling? That a chair, it is weighing, okay, suppose it is weighing 500 grams and I need to move it to the left of the room. So we are having magnitude also and we have the direction also. So this is known as vectors. I hope you understood physical quantity and also scalars and vector quantity. Now let us learn about speed. Distance covered by a body in unit time is called speed. Now what is speed? It is the distance covered in a unit time. Now this unit time can be seconds, minutes or hours. Okay, so in that particular unit time, how much the distance is covered, that is called as speed. The formula for speed is equals to distance upon time. So, since distance and time is a scalar quantity, therefore speed is also a scalar quantity. Next is velocity. The rate of change of displacement per unit time is called velocity. That means if there is a change, okay, so the rate of change in the displacement, okay, in per unit time, it is called as velocity. So the formula for velocity is displacement upon time. Since displacement is a vector quantity, therefore velocity is also a vector quantity. Okay, so the distance traveled in a particular direction by an object in the unit time is called its velocity. So here unit time can be 1 second, 1 minute, 1 hour, etc. So the displacement that occurs in unit time is called velocity. I hope you understood, children. Now let's go back to the picture on page number 1 of your textbook. What it says that there is a straight line distance between the houses of Sheetal and Sangeeta, and the distance is 500 meters, and that between Sangeeta's house and school is 1200 meters. Okay. Now there is also the straight line distance between Sheetal's house and school, which is 1300 meters. Now children, suppose Sheetal takes 5 minutes to reach Sangeeta's house. Okay. And then 24 minutes to reach the school from there. Right? So total in all, Sheetal takes 29 minutes to reach the school, and the distance she covered is 1700 meters. So, Sheetal's speed along path A. Okay. So, what would be the formula? Distance upon time. So, the first path is how much? 500 meter upon 5 minutes. So, after calculating, the answer comes to 100 meter per second. Now, let's take the second path. Sheetal's speed along path B. So, the formula is distance upon time. What is the second path she followed? 1200 meters upon 24 minutes. After calculating, we get 50 meter per minute. So, let's calculate the Sheetal's average speed. It is total distance upon total time. So, the total distance is 1700 meter upon 29 minutes. After calculating this, student, we get the answer 58.6 meter per minute. Now let's calculate the velocity. Sheetal's velocity is the formula is displacement upon time. So what is the displacement there? 1300 meter upon 29 minute. So what is the displacement? The minimum distance between the starting and finishing point. So it is 1300 meter upon 29 minute. After calculating, we get 44.83 meter per minute. So children, did you understood the calculation of speed and velocity and the difference between distance and displacement? Good. Let's move ahead. Effect of speed and direction on velocity. Now children, let's take an example to understand. Suppose the person traveling a bike, his name is Sachin, and he is traveling a motorbike. Now we need to explain what will happen in the following events during Sachin's ride. Now look at first picture. What will be the effect on the velocity of a motorcycle if its speed increases or decreases, but its direction remains unchanged? In case of a turning on the road, will the velocity and speed be the same? If Sachin changes the direction of the motorcycle, keeping its speed constant. What will be the effect on the velocity? If on a turning, Sachin changes the direction as well as the speed of motorcycle, what will be the effect on its velocity? Now children, it is very clear from all that velocity, it depends on speed as well as direction, and velocity changes by changing the speed while keeping the direction change. Okay, now when does velocity will change? By changing the speed while keeping the direction same. If the direction is not changed, okay, and only the speed is changed, so the velocity will also change. Now velocity will change by changing the direction while keeping the same speed. Now here we are not changing the speed. The speed is same, but we are changing the direction. So velocity will also change. Now if the speed as well as the direction changes, so the velocity will also change. Okay, the velocity changes by changing the speed as well as the direction. Understood, children? Now children, the first scientist to measure speed, distance, time. Now who was this scientist? He was Galileo. So he was the first scientist to measure speed as distance and time. The speed of sound in dry air is 343.2 meter per second, and the speed of light in dry air is 3 into 10 raised to 8 meter per second. The speed of revolution. Now what do you mean by revolution? The earth is revolving around the sun. Okay? So the speed of revolution of earth around the sun is about 29,770 meter per second. I hope children, all of you must have understood today's concept. What we have learned today is speed and velocity, what are vectors and scalars, and also we have learned the formula for speed and velocity. Children, after watching the video, please read from page number 1 till page number 3 to understand it better. We shall see you in the next video with a new topic. Till then, take care. Thank you, children.